Okay, so I wanted to give you a quick overview of the battery system that I'm putting together, and then show you the control scheme I've come up with for the Schneider inverter. But basically what you're looking at here is the battery out of a 2012 Nissan Leaf. It's about 5 years old now, so it's not quite up to full spec, but I'm still getting about 17 kilowatt hours in and out, so that's not too shabby. You can see that's all been rewired. In the original configuration, it's about 360 volts with all the cells in series, but they've been rewired with these bus bars, so you basically have blocks of 6 modules in parallel. There are 8 of those in series, and with 2 cells in series in each module, you get 16 cells in series. So that's why you have these center tap bars in the middle. Those are much thinner because they don't have to carry any current other than just tying the cell voltages together and connecting to the BMS taps. So I have a Batrium BMS coming from Australia, but in the meantime I'm just using these little CellLogs, which I think are a great little gadget for the money. Each of these will monitor 8 series cells. The basic ones cost like 17 bucks, and these ones for 30 bucks you get a USB interface and data logging. So those are a great little gadget to have around if you're working with lithium batteries. So basically what we're doing here is connected up to the battery is a Morningstar Solar Charge Controller. This is their 600 volt MPPT controller. This one will do 60 amps into a 60 volt battery, 3600 watts. And we'll be putting 2 strings of 1800 watt panels on it, so hopefully we'll be getting close to 3600. I've actually modified this guy a little bit, so there's a couple versions of this controller. This one has the built-in transfer switch, which is normally meant for switching between a grid-tied inverter, so you can connect the panels to the grid-tied inverter, or you can connect it to the battery charge controller. So I've rewired that so that I can have either the panels or a DC input into the charge controller to charge the battery. That will eventually get hooked up to our Prius. This whole thing is going into a converted school bus, which will be our RV and our home, hopefully in another few months here. And with the Prius towed behind us, anytime we need an emergency charge for the big battery, we can tap off the high voltage battery and charge up that way using the gasoline engine. So that should be kind of handy. It also has the little breaker next to it there as the battery disconnect built in. And then this one has the ground fault protection box as well. I figured since we're putting 300 volt solar strings on the roof, it would be a good idea to have that. And there's enough room in these boxes that I've added down at the bottom here some DIN rail fuse holders. So that's where the fuses for the each string of the solar will go, and another fuse for the input from the Prius. So that's how we'll normally be charging. And then over here we have a Schneider Conext SW4048 inverter charger. So this also will allow us to charge off grid power when we have it available, as well as has the inverter in it, which is going to be our primary power source off the battery. So this is a split phase 120/240 volt output. Nice thing is it's true split phase, so there's a neutral, and supposedly it can put out that split phase output, whether it's being fed single phase or 240 volt split phase. So that's kind of a nice thing too. So if we roll up at an RV park and they only have the 30 amp 120 volt, this thing should still work off that. It will charge the battery at half power and provide split phase output on the inverter output. That's also plugged into a comm box back there, so that gives us network control of the inverter. And I've got the AC box from Schneider also, which that will get filled up with all of the various breakers for our use in the bus. So this will be our main breaker panel. And then what's not hooked up yet that will go up in that space where the battery wires are coming in will be the DC disconnect box that was back ordered. So I don't currently have that wired in. So it's a bit of a mess out here, but I wanted to get everything set up on the bench and start doing some testing just to make sure everything's going to work the way I think it should before we go and try to get it installed. So then we've also got the remote meters here for the solar charge controller, and of course it's nighttime, so there's nothing going on there. And also the system control panel for the Schneider. So you can see it's basically idle right now. It's sitting in invert mode, battery at about 65 volts, and nothing much going on, but it's ready to go. And then this is the contactor box out of the Leaf. So I'm using that as my main battery connect and disconnect right now. So I've tapped off of the contactors in there as well as the pre-charge relay, and I've just got those set up on switches at the bottom there so I can connect the negative, then I can press the momentary switch to pre-charge, and then close the positive switch once it's up to voltage. And then I'm also using the service disconnect for the battery, so that's another way to disconnect it to make sure everything is safe when I need to work on things. So that's most of it. There's a power supply here, which is just powering the contactors for the moment. So eventually I'll need a DC to DC converter to supply that 12 volt for the contactors. And then what I've been working on today is this is basically a little control circuit that I built to try to interface the alarm contact from the CellLog up here. So it's got a configurable normally open or normally closed alarm port, and you set pack voltage or cell voltage thresholds, and that contact as well as an audible alarm will activate on those thresholds. So ignore everything off on the side there, that's all from another project. But the big purple caps there and the relay, the LED, and the phone cord breakout is what's currently hooked up to the Schneider. So the problem with the way I want to use the Schneider is this is their kind of budget line, I guess. It's not exactly cheap, it's still like $1,500, but compared to the XW Plus line, it's considerably more affordable. And actually, this does quite a bit for its price point, I think. But the main downside on this one is it does not have any kind of direct external control outputs available for the charger or the inverter. What it does have back here is a temperature sensor, if you can see where those phone cords go in, a temperature sensor and a remote switch port. So they do make this little switch box, which I've taken apart, but normally looks like that. And I've kind of tried to reverse engineer this guy. This is the board out of that. It's really pretty simple. All it is a momentary switch. There's a resistor and a cap in there, I think just for deglitching, in case you get any noise on the line. And then a little circuit to light up an LED. So by just figuring out what lines on the phone cord are connected to what there, I basically replicated that circuit over here on the proto board. But I've done a couple of things. So the LED is powered. just as it is on the switch port. So if you look over here at the Schneider, it is currently saying the inverter is enabled. Little green light's on. And so our little red LED over here is also lit. And the tricky part about this is, unfortunately, on that remote switch for the Schneider, that's a momentary switch. So there's not like an on-off. It's a, press and release, and when you release the button is actually when it engages, and then you press and release again to turn it off or turn it on. So that's a little bit inconvenient for hooking up to a relay, but basically all I've done is I'm using these caps between the relay normally open and normally closed ports and ground. So when you press that switch, all it does is it pulls that control line down to ground, and when you release it, the voltage rising back up is what triggers the state change. So this way, whichever way the relay goes, and the coil of the relay is just being connected to power by the CellLog, whichever way it goes, that cap momentarily draws the control line down to ground, and then it charges back up. That takes about a second. That's about the right kind of time constant that we want for that press and release action. And then I've got a small, these are probably 10K I think, resistor in parallel with each cap, so when it gets disconnected, it will self-discharge the cap, so it will basically be ready to pull the line down again on the next time the relay goes off. So this way, I get a short pulse out regardless of whether the relay is closing or opening. I get both edges, so that's handy. So I was going to try and demo that for you. Let's see how that goes. The batteries are fairly charged up, so you can see the half pack voltage here is at 32.78. So I've set the alarm for that just to 32.6. That's much higher than I normally would have, but that's about enough so that I should get a fairly quick action here, especially because that voltage is going to sag 100 millivolts or so once I engage the draw on the inverter. So all I need to do is come over here, turn on my AC out breaker. I've got about 3,000 watts of load on there. Those are just a couple of heaters that are plugged in. So we come over to the system control panel. We should see we've got 2,800 watts of power going out through the invert mode. We should see that voltage starting to come down. We're at 3.62. When that hits reliably 3.60 or 3.59, that contact will close, and I'll be quiet, so hopefully you can hear the relay. And there's the click. So there was a short click, and then about a second later you heard a louder click. That was the inverter actually shutting off. So the LED is now off, and over here on the control panel we can see that it's just sitting waiting for AC. There's no longer any load power going out, and the invert enable LED on the front panel has gone out also. So that is seeming to be working. I want to put it on a oscilloscope and just get a better idea of the timing, make sure that's the best cap value to use, make sure I'm getting kind of reliable performance out of it, but I think that basic idea is going to work. So when I get the Batrium in, it has both a normally open and normally closed relay contact that you can assign to the charge enable or invert enable function. So I should be able to use this same idea when the Batrium comes in. And then speaking of charge enable, I have been playing around with a trick using the battery temperature sensor. So that's what this guy is here. Also on a phone cord port. for the Schneider. So basically, room temp seems to be about 11 kiloohms. If you open that up, nothing happens. But if you short across that 11 kiloohms, then that will send the charger into a fault mode, which will disable it. So it's not maybe the cleanest way to shut it down, but that is certainly a way to do it. So that's one of the things I'm looking at for how to shut the charger down. Now eventually I want to have all of this stuff talking via proper network control, but in the meantime it's nice to have just a manual relay solution. So I hadn't been able to find any information on how to do that with the Schneider, so I wanted to share a little bit of that with you, and hopefully someone finds it useful. Thanks a lot for watching, and I'll keep you posted how things go.